vectors is just a list of the floating numbers, or the embeddings is same things. We are trying to see which embeddings are close to each other. They has similar meaning or similar context. A bit too abstract, right? Never mind, I'll give you a better example. So just take it as the concept first. So it's using the vector embedding similarity comparison, yeah. So give you this example. I think if you're doing not so many ladies, if you're doing shopping, right? Let's say you want to buy a cloth, yeah, Raya already finished. Want to buy her. So you can, some of the better website, the shopping website, you can actually search similar clothes, right? So how does it works behind the scene? Have you ever thought of that? You can. Oh, you see this person wear very nice. I don't know where they buy, what is the brand and why not. I just want similar one. Then you just capture the model's picture and then you just do a image search in your shopping website, right? So anyone want to try how you can build a search engine for this? So give you a very simple one. Don't think too much first. The first one is brute force search. I just compare all the image. I just compare. See which one looks alike. Right. This is, so it works, but it's not practical, especially if you have a very large database. Right. You cannot just do a brute force search comparison using a millions data. Right. So then, any other ideas how we can do a better search engine? So then we come to this, we call it AAN. I think it's being introduced by Google in 2015 or something. So then we remember we have all these embeddings. We want to try to group it together. Let's say very simple. This image, it can depends on how you do it. You can imagine that you can have different text, can be a sweater and then different colors and all, or different materials. You have all this in the embeddings. You just match, return all this, you translate into a query, right? Return all the data that it's a sweater, it have a red color or many colors and what's not. Then you are shrinking, reducing the, let's say 1 million data to maybe just 500. Because the others could be some other clothings, right? Dresses and what's not, and all these things. So then it's a much simpler way for you to do the searching, because now you have a much narrow data set to search between or compare between. Yes. Okay, can, right? So taking on this concept, we are putting it into this LM space. So we have the image, and then we want to combine the text. Same things. All these are embeddings. Remember, text can be converted into embeddings. Image also can be converted into embeddings. Then you just do the vectors similarity to see cross vector. It can actually populate similar things into similar groups, cluster actually. Then from the similar cluster, then you just do a ranking or search from there. So far so good? Easy, right?
So is it broken up into, would it search a part of that text first and then say grey tabby cat, and then, or is there,
right,
or is there a cluster which is exactly that sentence somewhere?
It can be different architecture design. It depends on you. You can put everything into the same one. You can just combine. I don't care it's an image or text. Or it can be, I want to filter by text first, then to go for image. So it depends on use case and how you want to design it. Yeah. Okay, right. So then it comes into the picture of vector search. You just combine all these different query, image, and text, same things. Then you have the ranking that is similar cluster. Then you just do the search from depending on the ranking. Ranking is rank 1 is the closest similarity. Sometimes because, oh, I like this dress, but I want shorter or no sleeve. So you can have similar but yet a bit different, right? You can do that. So far so good. Vector search, right? So it's very, very powerful in different business use cases. So I'll give you this like shopping dresses example, then you can see. So close result. Similar lemon, but is like one is very close, one is a bit not so much of lemons. Can be short or long and all these things, or big lemon, small lemon. So especially like for fashion industry, you can directly apply and can do a very powerful search on that for different products or recommendation. Okay, just a quick wrap up on this vector search. So Vertex AI vector search is a managed service in Google Cloud. So you can just throw in your data inputs, it will generate the index and do the indexing for you. So but you have to pay. If not, then you take out this part, vector search, you replace with a different vector database. Right. So it's the same thing. So also good, all good. Very last LLM. We have the LLM model. I don't want to go over too much on the Gemini and what's not, but where the LLM sit in the RACs system, right? So this is again the standard or traditional how the LLM works without RAC. So I just give it an input prompt, send it to the LLM models. You just give me the answer, right? So this is you ask a question, you get the answer. Very simple. Then you will have a lot of funny answer coming up from the model. Then we want to improve the accuracy, right? Or you want to also add in our in-house data. Then we come into this external knowledge or external database for you to be able to answer the latest data, latest question or in-house data, private data, all these things. So it's an extension or improvement from the basic LM architecture. And why everyone talking about RAG? Because you always will need RAG, right? Now, I will just use the same things. You can connect to different LM models. In Vertex AI, there are different foundation models available. Gemini is the one that's from Google that we want to promote. But other than that, you also can find open model like Mistral, Gemma, all these different models in available on the foundation model garden in Vertex AI. So how the LLM works is, remember, I simplified. You have the input data, send it to LLM, and then you will just get the embeddings, right? But what if you have let's say very large documents? So you actually chunk it to a different smaller chunks because it cannot process too big. Of course, with the bigger context window size, the LLM can handle, the lesser chunking you need to work on. So the context window size is actually quite an advantage in Gemini because you just not need to be able to process 1 minute video. In real case, there's no 1 minute video, right? Unless you are doing the TikTok video. Yeah. Then how you want to do a summary of 1 hour movie video? Cannot do that. The LLM is like out of memory. You can just connect directly, send it. So you have to split it into small chunks. 60 minutes. So you have to if the LM context window size is just 1 minute, you will have to split into 60 chunks for it to process. And then you have to combine different summary in the 16 chunks to form a summary at the end. So there are a lot of hard work behind the scene. Then then you add in the private data, so you embed into it, then you can generate the response, combining the information from your internal data. So this is where the LM come into the place, right? LM, just put it back. So the four models from Gemini family, and we have the Gemma models also. Right, just a refresh on all the RAG architecture. So this is simple. You have the question sent to model, LM models, you just reply it directly to the user, right? Then you have the problem or limitation of you don't have the latest data or answer, or it's outdated, or it can be a hallucination. So adding it into RAG, so it's actually just adding into your vector DB, your in-house DB. Then you can give a better accuracy on that. Same things, this is just a better scenario or a use case. So what does the warning light means on my car? This is a standalone LM, right? It give you a question and then you directly get the answer. But in RAG, you can have a very longer process. So you from the question, you will just generate the query embeddings. That means this question will be transformed into embeddings, and then you do a vector search into your vector database. See, let's say if you already have in-house product catalog and what's not. So I want to search this warning light in your product catalog or your policy and all this in-house document. Then if you found it, you just get it, right? Because it can be only still confidential or still in R&D of your in-house house, but not available in the external world, right? Then you do the chunking and all, then send it to the LM. The LM will be combining the result from the vector data search as a final answer for you. Then you don't have a funny answer giving you wrong answer confidently. Very all this LM, right? So a quick one on the RAG patterns, coming to a bit on your question just now. Is it something that text first or image first or everything's right? You can do differently. So one way is you have the text, then you search the vector, and then you just retrieve the text. Or you can be also multimodal. Do a vector search, or you can combine both and then retrieve. You can depends how you formulate your prompt also. You can return into JSON or you can return into image and different things, right? So these are depending on use case or how you want to develop it. It's a bit flexibility here lah. Yeah, same things. This is more towards into a Q&A pipeline already. The graphic here is actually the same flow. So inputs turn into embeddings, and then you do the vector search. Output sent to the LM, and then answer return to a user. Bear in mind, this is just an example, not the only one flow. Yeah. You can have more very advanced, complicated one, and also can be introducing the AI agent into the place.
What's the best way to have the database? What is there any better ways of having the database?
Vector database, different between database and vector database. Anyone? Vector database store embeddings, all the vectors. So it's called vector database, just that. Instead of the string, this is the normal database. If I can quickly find you the table one. Yeah. This is your database.
So, yeah, so say for example, you've got a client, and so it's better to retrieve the information based on them filling out a database like this, like a table.
Yeah, the one, if you do that, is like I say, the conventional keywords search or matching. Yeah.
And then they provide it to.
If you store as a vector DB, there's no way you can say if it's 0.1. It doesn't make sense, right? Yeah, it's just that. So yeah, some database is normal database, some are vector database. Good question. That means you are following. Thank you. So now, talking a lot of all these things, let's look at the quickly on all this and learn, and then the rag and all we'll cover, and then let's try to look at some coding and examples for you to try on, right? I think I have some slides, but some of it I'll go through directly to the collab. So where does the multimodal rag in Vertex AI is here? Vertex AI search. So the grounding part is here, the generation. Then you have the grounded response. So I wouldn't go through into details on all the different methods here, but let's just take one for example for you to get some ideas, and I'll share the collab notebook also. Then if you have time and must not, you can go through it on your own also, then to get a better understanding. So just now the RAG API and all, you have different process and you can do different things. But all the things I already covered just now, you from the different input data, you want to first convert into embeddings, right? So you have the embed API. Then we want to also do save into the vector DB. Then we want to be able to index it so that it's in a better searchable way lah. Then you can also easily to retrieve from the vector DB and then do the ranking and generate the response from it and do validation or grounding part. So all these are available in Vertex AI. But if you are using different framework, then you may want to check on data. So for this example, right, multimodal rag in Vertex AI, I have two PDF files. So it's you have the text and you have the tables. I want to see if I can have a search or some question related to the table or some related to the text that link it to the table and what's not. So then we want to try different scenario. Extract store the metadata of text and image from a document, and then inspect the processed text metadata and also the image metadata and do a text search or image search for now. It maybe a bit too small, no right? So these are the data being extract out, being processed. It's being actually stored in Google storage. We try to download and process it. So these are the text metadata. So here you can see the chunk text and also the embedding chunk, right? Then we have the image metadata. Similar things we have from the PDF file here. The image is not the different image that I put in. It's the image that it extract out from the PDF file. Or this table is an image. So then you have to save it as a separate image file, and then have the from the image, let's say table 001.png. Then from there I convert into embedding also. Then from there I try to implement functions, reg helper functions. So here you just call a different API from the libraries already. Is actually pretty straightforward. Then I just call a text search. You will see that it's doing like this with the citation. What are the similarity score and which document is actually referring to, and the page and the number chunk and the text. So this is for the use case of the text. Then the next one, but if another question, right, if I want to ask about, is actually the information is not in the PDF file. I mean, it's not in the text summary, but the information is available in one of the table. It's actually able to do that also. The Gemini is, if you put it's just query as a text, then you will say you will return the result not available in the context, because from the text you cannot find that answer. But if you combine the image, then you actually return it. If you want the product ABC or the sum of it or things like that, then you is able to retrieve a relevant image diagram for you. But if you look through, do a keyword search, all these things, you will not be able to find it, because it's actually converted into a table image. Right. Let me show. Not sure if I still can show you this. So these are the different things. So if you can do the image search and all, then also for it to combine the matching images similar on the comparison, so you can actually do, it knows it will knows which image looks similar or is doing similar or representing similar things. So let's say I do a forecast or things like that, or the other image also similar forecasting. So you can actually know which is more relevant and return it to you. So all these different things, you can take a look into the more details here. I think one thing I want to show is no. Yeah. So here is if there are question that if you are combining different images, also is possible, when you will actually be able to answer according to multiple images diagrams to generate. It depends on your questions. Take a look on this. I wouldn't be going into more details, but if I have a bit of time, let's see if this works. So this one is a LangChain one. Initial setup. So it's actually here. I'll just quickly go through for you. So if you want to building the knowledge-based system end to end and with more directly to link it to the production data and all, right. So here is the workflow steps that you want to do. So first is create the documents from Vertex AI, and then generate the embeddings, and then create the Vertex AI vector store. Let's do the search, and then you can just create a rack using the LangChain directly. So it's very simple in the steps, but of course there are more in more details in each steps that I wouldn't be be able to go through with you in details, but you can take a look on this one. So so the API is very powerful already. It's very easy for you to apply already. When you have the different concepts in mind, then it's easy for you to know what you want to build. Then applying into API, because you know what you want and what is happening behind, is easy already. It's just not calling API, just throwing random things and see and don't know what is happening, right? So now you can actually easily apply the knowledge of different concepts just now into the pipeline system. So I just load the documents structure. You can see here some example here. So there are 32 pages documents. Then you want to create a different document chunks, split into smaller chunks for it to process. And then you just generate the embeddings from each of the document chunks here. and then you just store it, create a vector store and store it inside all these embeddings. You just store into the vector DB and index it, and then you just search the vector store and get the result, query result as your answer. So there's one way is without using the LangChain, and then also you can easily using the LangChain. So there are two different examples for you to refer to. I'll be also sharing this notebook for you, but to be honest, you may need some cloud credits. That's why I don't really go through directly hands-on with you. So far, so good. Any other question? All good. All good. So we have covered a lot today. Summary. So remember, RAG, external data DB, especially on vector database that is storing all the embeddings from your different data. It can be text, it can be image, it also can be audio file also. Then so RAG is just a concept, but it can be from just text. You can combine multimodal is different input data, right? Image, audio, and all. Then you can even have a much enhanced system. You can have a better knowledge base, because now you can not just deal with image. Not just deal with text. You can also apply it into images and all. Then you can also improve the reasoning and the accuracy from the model. And we have gone through a simple collapse on how to do the generating the embeddings, and then do the text search images, and then also to go through the different scenario using the LangChain and without LangChain. Although I don't go through into details, but I'll put it into the slide. You can refer it later. Yep, I think that's all. Any other question? No, all good. Now everyone can answer RAG. Try to build the RAG. You will see a difference. The LM, how the LM answer without RAG and with RAG, you will see a difference. Okay, thank you.
I'm not gonna lie. It's me right now.
Hello. Hi guys. So we'll be taking like a 15-minute break, and then we'll continue with the next talk by Matthias in 15 minutes at 3:45.
I was like, I want to do this. Yeah, I want to do it. You know, what was the that would be nice. It's been a long time. I'm thinking like and there's no choice. Yeah. Yeah. I think I'll look at data. I mean, mine is very Gemini. I would say Gemini Pro 10 times. I promise you. I mean, maybe I should. No, for iOS. Like now we're no, Chris, reaching SWAT. I think everybody knows that. Like it's probably thousand. Somebody told me about this. That's so But sorry, you going? Is there anyone? GDG, let's make a GDG. Yeah, wow. I want to be right. I just want to yeah, that's what I'm Let's do it. Still works. Which one is it?
Been working hard. I think you can just directly join the Google Meet.
It's
It will be share screen because they want to do the broadcast.
It
Just you
works
make-
like this.
Yeah.
Okay, interesting. Because then how am I gonna do it? Because I'm showing code help.
Just share the whole screen.
Hmm?
Just now I just share the whole screen. Yeah, I go. I keep everything in the same. Same.
But you didn't have speaker notes.
Oh no.
Let me try some.
I think it's possible to share in a different way, but I don't really know if the speaker not.
This looks like.
And
Yeah, let me try this one.
Did you join the call?
No.
You would have to join and present.
yeah,
Well,
he wants to have a reference of the speaker note also.
Oh, you can as well. When
How?
you share it in the call itself, you can click on the three dots and then open up your speaker notes.
Oh, like come to rescue.
Okay, it was here, right? Track one?
Awesome.
The thing is, I'll be jumping to different screens.
It's what I do is normally I'll just put all the tabs that I need in the same one, and I'll
Just
just
switch to share this tab option. Because they are live streaming it as well. You do in the call.
Okay, so that's I turn off. What now? What now? What now? What now?
Let's try again.
Was this live stream?
I think so.
Great. I think let me get some water.
oh because it's here. Everything is
No, it's not. No, it's not.
Let me go check outside first if the live stream is going from the.
Okay. Should I turn off my sound?
Did we?
Why have we turned on this? I did that.
Okay. That
Then if I Wait, that's how we should do it. Wait, let me. Yeah, maybe that's the. Okay.
you know, right?
Okay. Cool. It's working. So not to say. Okay. Awesome. And then if I want to switch to,
You
let
just
me.
go. Oh, you want to switch to here? Then you need to share your screen. I will stand by here. So later when you wanted to step, you just.
So I
45
just
minutes.
present something else, and then I go.
No, you need to change it to entire screen because VS Code is outside.
Oh, but if you share entire screen, then the notes would be visible.
But for VS Code, that's fine.
Yeah, yeah. So you
Entire
just share
screen.
entire screen and
And
then
then-
set to VS Code or Western Code. Yeah.
Yeah, I have all my work stuff open as well.
Yeah.
But then I can share data group. I can share VS Code. This
Yes,
one I can
yes, yes.
close.
That one definitely need to share screen.
I can share also this,
Mm.
and then at the end I go back to sharing the tab. Am I sharing the tab now, or
Yeah, you're sharing now.
can I share the full screen?
Oh, then there are notes.
Window should be fine,
Yeah,
right?
Windows fine.
I think so. Let's try. Okay, then
Okay.
Oh, it's my
no,
turn.
no, this is not the one. Uh-huh. Okay.
Nice.
Okay,
Yeah.
yeah, there you go.
All good. So let's start.
Yeah.
Awesome. Everyone, still awake? Sorry, some technical problems to work through, but I think we're ready to kick off. Or we're not ready to kick off.
No issue, no issue. Continue.
Okay, I'll continue. So yeah, first of all, thanks for sticking it out until this part of the day. I think it's quite late already. So I don't see too many sleepy faces, so that's good. Quick intro, I'm Matthias. I'm a software engineer with a background in data, cloud, and a little bit of AI and ML. I'm currently based out of Singapore, where I'm helping our clients doing the best with the cloud they can. As a senior data cloud architect at Do It. And actually, funny, one of our clients is Pinecone, which is a vector database, as Leifeng was talking about before. So it's quite relevant to today. So we'll be talking about RAGs as well, actually. But as you might have guessed, it will be also about GenAI. And I don't have actually a lot of slides today. So I hope you guys are all right with diving into a notebook later on. Sounds good? Awesome. So for the agenda, I will kick off a little bit with a personal journey of GenAI for myself, how things went for me. Then I'll give a quick intro to the problem we're trying to solve. So basically, we're trying to help recruiting agencies to, well, in this hypothetical scenario, we're trying to help recruiting agencies to match job descriptions with CVs. And we'll see if GenAI has a role to play in that. And finally, I will basically walk through a step-by-step example where we introduce some of the tools and some of the concepts that are relevant to solving this problem. And it's actually the first time I'm giving this talk, so you guys are my guinea pig audience. So please come along on the ride and have some fun. Probably not everything will go perfectly. So to kick things off, my personal GenAI journey. This picture was taken at the end of 2022, around the time that ChatGPT was introduced. And I was still having some COVID blues back then, and I really didn't want to jump on the AI hype. I was like hiding away from everything large language models and GenAI. I was like, nah, I don't really want it. But that was actually the case until deep 2023. But my friends thought differently. They were like, yeah, GenAI is the shit. Like, let's do some stuff with it. And you can probably see some similarities. They did have some good fun with that. So that was the start of my journey. I think it's a pretty good one. The closest I actually came to doing stuff with GenAI was about a year ago. I was going to IO Extended in Bangalore, and I was pretty much seeing the things of that Google was doing with BART, and I was trying to compare them with ChatGPT outputs, and I was noticing some of the differences. So this was about a year ago. But then come September 2023, my manager was like, okay, I think it's time for you to look into GenAI. So I decided to start dabbling with it a little bit. And quickly I found it quite useful. So I was working on a game, Rock, Paper, Scissors, if you guys are familiar. And I needed some visual assets. And this is what came out. So the splash screens, like start the game, play Rock, Paper, Scissors to entice people to play. And even the gestures, they're all GenAI generated. Yeah, GenAI generated. It works. And I quickly saw it was useful, not only for generating pictures, but also to write some code or learn about new concepts to me, like computer vision and gesture recognition, things like that. So in the end, I decided start of this year to take a course, one of Stanford's online courses on natural language understanding to get a bit deeper into the basics, which was super interesting. And today I'm actually kind of probably using Gen AI and on a daily basis, which is quite cool, exciting times. And yeah, the summary of my relationship to Gen AI in 2023 is like, nah. 2024 is like, yeah. So I've been trying to figure out a little bit where Gen AI is going, and probably you guys are wondering as well. But yeah, apparently even Sam Altman doesn't know what's next. So I think it's a bit more complex than we might want it to be. But let's take a quick look what I was able to find so far. And I've kind of split up the things in success things, so the good, then the more harmful things, like the bad things, and then the ugly, the more the to me funny things. But since my mom told me to always start with the bad news, so we should start with that. So my first reaction to dabbling with Gen AI, and especially as a software engineer into code, and maybe some of you can relate to that, is like, okay, it's over. We can go home and maybe work the land for the rest of our days because my job's gone very soon. And there might be some truth to that. According to Goldman Sachs, 2 out of 3 occupations in the US are to some degree exposed to automation by AI, which is quite scary. And yeah, this is one of the South Park memes that immediately came to mind. Kind of related, but slightly different is the things that were happening in the creative industries and the backlash that people were seeing. So this is an example of an image that was AI generated and it actually won an art fair, and people weren't very happy with that. Obviously, other artists were like, "That's not real art." And also we saw Hollywood, where people were protesting against the use of Gen AI in their industry. And this doesn't relate only to people potentially losing their jobs, but also to the data that has been used by the models to create some of these newer pieces of data, actually the generations that are the output of LLMs. And the question is kind of still out of who owns this data. Is it intellectual property of the creators, or is it something that tech companies can freely use to their heart's content? And actually, some of these questions are still being answered by courts in a number of quite high-profile cases. Also, there's misinformation. So we shouldn't be forgetting about the fact that we're dealing with a stochastic system. It's not code, it's not deterministic. Anything can come out of it, kind of. And I assume, who has heard of hallucinations? That's, yeah, more kind of half the people. So yeah, hallucinations are outputs that an LLM can create, and it's kind of where they sound very confident about saying something, but it's actually nonsense that's coming out. And a lot of the research in industry and academia is going into counteracting these effects. For example, by making more truthful data sets, training in a different way, or as you might have heard in the last talk, architecting the system differently with retrieval augmented generation. A bit more on that later. On the positive side, and I couldn't keep myself from adding this one. It often leads to funny results. I don't know if you guys have seen when you ask an LLM when your cheese is falling off your pizza, what you can do to stop it. It's maybe add some glue. It's just like quite a funny thing that comes out. And so we can see that even titans of industry are not immune to these things. So I think it's good to tread carefully in this direction. And then the last one, and I don't want to be full doomer, but there's people saying there might be existential threats to humanity. A lot of AI leaders in industry, as well as leading academics, have been sounding the alarm, but there's also other ones that are providing a healthy counterweight, like Jan LeCun from Meta. He says, we're not going to walk blindly into a situation like that. And luckily, Ilya just left OpenAI, and he's starting a safe superintelligence company, so we're all safe. A bit more seriously, I think DeepMind has formed a new organization that only works on safe AI, and I think that's it's giving me some peace of mind that will be at least kept in mind in the future. Anyway, enough doom and gloom. There's also a lot of good stuff. according to Goldman Sachs, we can, with Gen AI, increase the global GDP by 7 to 10%, which is 7 to 10 trillion, which in turn can lead to things like more investments from public sector, higher salaries. People can have a better lifestyle in general. So this is, I think, quite nice for everyone. And I think many of us have already seen the productivity gains someone might have. According to a report from McKinsey, it can increase our productivity 60 to 70%. And this leaves more time and space for higher level thinking and things, spending time on things you might actually care more about than the menial work we were doing. Who of you has used Gen AI to learn about a new topic? Well, that's not too many people. I don't believe that, actually. I believe there's a lot more people than that. But according to the WEF, the World Economic Forum, Gen AI could be the next society's new equalizer, basically, and providing a lot more equal opportunity to everyone, which is obviously a good thing. And then lastly, I think this is a very interesting talk from Andrew Ng. There will be more business opportunities, and I think it's a good talk to watch if you're interested in seeing the lay of the land and how Gen AI actually differs from the previous versions of AI and how it can help you spin up a business or make a product faster by incorporating AI. But my favorite part, the ugly. I don't know if you guys have seen the Pope in a puffer jacket. It was my first time I felt like a boomer because the first few seconds I was looking at it, it's like, is this real? Turns out it's not. And yeah, I really like the person that came up with this, like, very gangster Pope. Another few examples that I really liked. I don't know if you guys have seen Dream Machine by Luma. That people have used it to basically animate some memes into actual videos. This is like the jealous girlfriend one. One of my favorite is the disaster girl, which has a very ominous smile. Doge, Mark Zuckerberg doing creepy things. Yeah, lots of good stuff on the internet, right? Let me find those back. Yeah, another one that have you all seen the trend, like make it more X, like make it more this, make it more that? So they applied it to Belgian guy as well, which I'm hoping it kind of looks like me. I'm from Belgium, by the way. So I think this is probably Ghent or Bruges, or maybe Brussels. And then make it more Belgium. We add beer, we add waffles, we add Belgian flags. That's absolutely amazing. Then chocolate on fries. I mean, this is full Belgian. Don't try at home. But yeah, it gets more extraordinary from there. Like more beer, more carnival, more medieval houses. It's absolutely amazing. But my favorite, I think, is Will Smith eating spaghetti. I think this deserves at least 10 seconds of our time. It's one of the better things on the internet. And obviously, the best part is always in the comments. It's like, if you add meatballs, it turns into this. So yeah, that's been the fun part of my Gen AI journey. And basically, yeah, moving on to more serious stuff, I guess. Can we use Gen AI in job matching? That's kind of the topic, and my title was also Gen AI generated. But yeah, that's kind of the question I was asking myself. Can we speed things up and make things a bit easier for recruiting agencies or HR persons? So when people try to look for a job, like usually the first step is when the CVs arrive in the company, people will have to filter. Like I've been hiring for interns at some point, and we had like 250 CVs. I went through all of them step by step because we didn't have any software for it back then. It takes a lot of time. It's kind of fun, but it's mostly taking a lot of time. Things improved a bit. We have keyword matching nowadays. We have semantic search, but yeah, LLMs definitely can have an edge here because we basically have two bodies of text that we're trying to interpret and see if there's a match. And LLMs can definitely help there, having some more context, having some more interpretation on what skills can match which part of the job description. And I'm going to apologize here, but I think some of the things might have already been introduced about RAG, but we'll be talking about RAGs again. I hope there's some new stuff for you guys today. But I basically use the RAG architecture to achieve this. So the CVs will be the documents in this case, and we will retrieve them and use the job description as an input. So RAG is actually nothing new. The paper was authored in 2020 by some Facebook researchers, but it has been growing exponentially kind of in popularity over the years. And this is one of my favorite blogs that I've read in 2024. It's Berkeley basically did a survey of what people care about, and they saw that in the LLM space, a lot more people are incorporating LLMs in kind of a whole engineered system. So they call it a compound AI system. So I can highly recommend this blog post if you're interested in reading more about this. But yeah, basically RAGs are kind of very hot right now. That's probably why half of the talks are about it as well. What happens under the hood? We have, can you actually see? Yeah, you can see this, nice. So we have our documents, in our case, the CVs. We have potential, we can chunk them, but if the documents are small enough, we can just fully embed them. We will get the vectors out of that, the embedding vectors, and we will store these vectors in a vector store or a vector database. And then while we are giving our input certain query to our LLM, we will retrieve the most relevant vectors, and we will use this as context for the other LLM to generate something that basically do something with it, with this extra information, with this extra context. To, in the end, provide us a hopefully more relevant answer than just a general LLM can do. Cool, time to build. Everybody ready? Let me figure out how to switch the screen to VS Code now. Let's see. Present something else. Window. I have to share the window only. I think the entire screen. I won't have the audio and the code.
Oh yeah.
Okay, I'll do some more switches. I have a few I have a few things I want to show you guys, but yeah, this looks good. Can you actually see, or is this too small? Bigger?
Okay.
Let me. Is this big enough?
Yeah.
Yeah. Okay. Let me close a few things so it becomes easier to read. So obviously we need a data set. I was looking for CV data sets on the internet. It's very hard to find, I think, mostly because people don't want to share all their personal information. But I did manage to find one on GitHub. It had 65 CVs and 5 job descriptions, which is not a lot, but why not start with there, right? First step, some pre-processing. We want to make the data available in Python, and we want to do some stuff with it. And obviously, pandas comes to mind. Very easily to install. We pip install it, and we look at our job descriptions first. So the input data looked something like this, just a CSV with the job description, the job title, and some non-relevant other information. And reading it in, it becomes just a pandas data frame, a little table like that. Looking at one of the job descriptions, you can see it's quite long. So the total amount of characters is 3,600 characters, which I'm too lazy to read that. Like, I don't have the time to go through that. So this is where I want to introduce the first tool, and I think this is actually quite relevant because, like Fung was talking about, GenAI being very expensive before, which is true, but there are ways to do it locally and for free. So I hope you can take this away and home and take this away to try at home. So yeah, our job descriptions are a bit too long. So why don't we look at trying to summarize them with the help of an LLM? Has anybody heard of Olama before? Oh, quite a lot of people. That's good. I'm impressed. So I think it has, first of all, the cutest logo out there. But other than that, it's quite easy to install, and it allows you to basically run a large language model locally and interact with it. So we can do that on the command line. I've actually pulled a few models already. So we have Gemma, we have Llama, different sizes, and we can interact with it just by doing a Olama run Gemma 7b. So we're gonna talk to Gemma today. Oh, I lost my screen here. It's back. So it takes a little bit of time to load in the parameters, but here we go. So let's see if we say hello from Google I/O extended in Kuala Lumpur. Let's just say hi to Gemma. It's giving us something back. It's thrilled to be part of Google I/O extended. And let's say hi to the audience. So awesome. Just say hi to you guys. Say hi back. No, we can say bye. So we can interact with Olama, with Gemma through Olama on the command line, but obviously there's also Python API, which is the one we're going to use today. So we can simply import it. I defined a little util function that will help us with the summarization. We define the column we want to summarize, and then we have the prompt. So we're basically asking Gemma, please provide us with a concise summary of the job description. We define the model, and then we will run through the data frame we just created and summarize all the job descriptions. So this took about 1 minute to summarize 5 job descriptions, which is arguably quite long, but at the same time quite short, because if you would summarize them all manually, it would take a lot longer. And it comes back, I was actually quite impressed. It's a nicely formatted version of what we saw before. So we have a proper job description, the industry, key responsibilities. So it kind of makes it a lot more digestible for you to understand what the job description is about. And the total length was cut down to 922 characters, which is about 4 times shorter. So next up, this was the job descriptions. Moving on to the CVs. These were basically made available in docx. So we have 65 docx files here. I don't know why they did that. It's not great, but anyway. You have a Python library, Python docx, that allows you to read and parse these files. So I defined a little function that tries to keep some of the formatting, because obviously you can do markup in a docx file, but in plain text it's kind of lost. But I tried to keep the paragraphs by adding enough line splits and some bolts and italics. Let's close this guy down. So we look through all the CVs, and then we basically apply this function that I just shown to all of these files, and we read them into a pandas data frame, and we end up with something like this. So just CV text, the length, I calculate the length as well, and some other metadata. And some statistics. So there's one empty CV for some reason. The largest one is about 5,600 characters, and then there's the average length is just over 2,000. So put it in our vector store and do some retrieval, right? So the tool I want to introduce, and we saw vector search before. I think, like Feng also already mentioned, that there's other options. There's plenty of options. I mentioned Pinecone, there's Chroma, there is Elasticsearch. Like basically everybody claims to be a vector database nowadays. But one of them I think is well known, widely spread. I mean, who doesn't know? Is there anybody who doesn't know Postgres? I know Postgres. So Postgres is kind of, like industry standard. I think it became the most popular database again this year on Stack Overflow. And they've been developing an extension called PG Vector since 2021, which will help you with storage and retrieval of vectors or embeddings. So why do we need it? We want to find those pieces of text that are the most similar to our input data. And with this extension, we can all basically do it in an environment all of you know, actually. So that's great. Running it locally is also super easy. So they provide an image that already has PG Vector installed. And you can just Docker run it and add some environmental variables like the username, password, etc. I did that before the talk. So we have PG Vector running here. And it's ready to go. I don't think I have to introduce embeddings anymore. Anybody wants me to introduce embeddings again? Maybe I can skip over this part. Okay, I will skip over embeddings. Then I think another tool that is very popular in the space is LangChain. So it's a framework that helps you build applications that incorporate language and make it possible to do more complex workflows than just here's a prompt and I want the output. Over the past year, it's become like 10x more popular. So it went from like 10,000 to almost 100,000 in a little over a year, which is, you can do a lot of things with LangChain. I haven't seen the end of it myself. So maybe next talk I will talk about another part of LangChain. But basically what we want to do today is use the Ollama embeddings, so the local model that we have running, which can also be Mistral or Llama, anything you want. So we import that. We have the documents, which is basically a representation of the document in our vector store. And then we have our vector database that we will be importing. We construct a connection string. We have a collection name, and we define with which model we want to make the embeddings. With that, we just construct the vector store. So these three variables go in there. And then we iterate over all the rows in the pandas data frame to basically parse them into documents. And with one simple API call, they basically go straight into PG Vector, which is running locally. I ran this also before the talk. It takes about 2.5 minutes. And I can actually, let me try and show. To present something else window. I will show what it looks like, and that went better than expected. So this is DataGrip. It's basically a tool to interact with your database by the people from JetBrains. And we have I've connected to the local database. There's a LangChain database in there that was created, public schema. There's two tables, one with the collections. So we just have one collection for now. And then all the embeddings. So we have 65 CVs that are now represented as actual vectors. So this is what happened in the background. So we threw the documents at Gemma, and this is what came back. So back to the VS Code. I thought this part was gonna go horribly wrong. But here we go. So we have the vector store, and now we can retrieve our documents from it. We have different search types. We're just gonna do a similarity search here, and we're gonna get the 5 most relevant documents back for the certain job description. So we feed it the job description I was just showing, and we get these 5 documents here. Also, the CVs are extremely long. I don't know why, but these are the 5, according to Gemma, the 5 most similar documents to the job description. And basically, when you're doing similarity search, you're trying to minimize the distance between the different vectors, like your input vector and the vector it's trying to find. There's a few ways to calculate this distance. The default one in LangChain is cosine similarity, but it allows you to change between Euclidean, cosine, and inner product as well. So we have our vector store, we have our model running locally. Now we're pretty much ready to do our local RAG. But before we do that, I want to introduce prompt templates. Probably you're familiar, but I will just go through it anyway. So prompt template allows us to basically give a blueprint of the thing we're going to feed our model. In this case, we're going to input the job descriptions as a variable, and also the retrieved CVs from our vector store. There is one resource I want to point out, and I'm going to have to switch again. There's a prompt engineering guide, which basically has a few. I have too many tabs open. It has a few resources. Here we go. So it has some resources for you to check out, like different techniques on prompting. I think chain of thought prompting is the one I used today. So basically, it allows you to force the model to reason through the steps it takes to end at a certain solution, which will first of all help it come at more reasonable answers, as well as give you some insight at how it arrived at that answer, and hopefully give you some more confidence on the way there. So other than this, in the prompt engineering guide, also interesting, there's the different models. So for this particular one, I was looking at Gemma. There's a description of the model and some tips and tricks on how to basically handle that model. Back to the code. Here we are. So yeah, this is our prompt template, and here's basically the chain of thought part of that prompt. So I ask it to provide the favorite candidate out of the CVs it retrieved, but also tell us step by step on why it chose that candidate. There's also little formatting docs, but that's just a utility function, not very interesting. So the tools used on the way, open source models. So let's talk about them. At the start of the big AI boom, there was mostly proprietary models. I think GPT-3 was probably the one that was most widely spread, or like it was an exponential part of the curve. And open source lagged quite a bit behind at the start. Actually, the first people to come out with one was Illutor AI, which was a research group that tried to mimic GPT-3, and later on Meta jumped on the bandwagon, and also as well as the big science research group. There's a blog post that goes into a bit of more history that's quite interesting. Maybe I can. Yeah, it's gonna be. I have to switch again. I thought this was gonna be easier. I was gonna show you a lot more links, but yeah, if you Google the history of open source LLMs, and you see a Substack by Cameron Wolf, that will lead you to a quite interesting blog post on the history there. Obviously, Google couldn't stay far behind, so they introduced start of the year Gemma, which is based on the Gemini research and technology, and conveniently, as we saw, we can run that in Olama. For people who are wondering, the best performing models, there's a Hugging Face leaderboard that kind of lists, according to certain metrics, which are the best models out there currently. Although there's some discussion about if it's a good thing to have, because some people see the metric as a thing to optimize for, which is not always necessarily the best for your use case. With that, I think we can move on to the chain. So the final, actually the RAG itself. We're putting everything together now. We have the Olama model, so it's going to be Gemma again, and the RAG chain it's quite an easy one. But we have the job description and the CVs, which are coming from the retriever and going through the format docs function. which we feed then to the prompt template and at the end to the LLM, and we get some output. So what does this look like if we show it a job description? So first of all, there will be 5 CVs that it retrieves, and I actually printed them out. So it retrieved CV 59. There will be a few other ones, 37, number 5, number 52, but completely at the bottom, we will have the actual generated text based on these retrieved documents. So the best candidate, according to Gemma, is going to be candidate 3, which is the CV 52, and it gives us a few reasons why that is. So apparently that person has extensive expertise and experience. It has strong technical. Oh no. It's still moving on my screen. It's working on my machine. Okay, I'm not sure what happened. I'm still sharing. I'm still connected to the internet. Present something. I'll just stop sharing for a second.
Yeah.
Go back to.
Your CV selected, right? So you're not experiencing.
No, it doesn't work.
No?
Oh no, it's moving again.
Okay.
Nice, thank you. Cool. So yeah, it gives a few reasons on why this person is a good fit. So this is, I mean, if I were a recruiter, I would be very happy. Like this is doing a lot of the legwork for me, and it probably trims down finding a CV from hours to hopefully minutes. One thing that I was thinking while developing is, though, we probably don't want to keep this thing on our local machine. So at some point, we're going to move this to the cloud. It can provide a few things like scale, other enterprise readiness, things like that. And that's why I think Google Cloud can offer some things that give us an advantage. And one thing that is also relevant is the concept of a context window. As you might know, Google loves to brag about their 2 million context window. They have the latest model that they announced at Google I/O has 2 million tokens available, while the Gemma model that I'm running locally, and that is also already quite slow, just has 8,000 tokens. So imagine on average, if you want to retrieve a few CVs, we're kind of limited at 5 CVs with Gemma, while with Gemini, we could go up to 1,400 CVs. So hopefully out of those 1,400, there's going to be one that matches our job description better than just the 5. So obviously on the cloud, we will also need a place to store our embeddings. And so we had Postgres at the start, but Google did something to Postgres and made it even better. So this is covered under their LODB offering. They also have Cloud SQL, which is just plain managed Postgres, but LODB is claims to make OLTP transactions 4 times faster and OLAP transactions 100 times faster. So there must be something they're doing right. So what we basically need to do is repoint our embedding and our vector store to LODB instead of our locally running Postgres instance. But this could also be vector search, it could be ChromaDB, it could be Pinecone. A lot of these are also in the marketplace, I think. So yeah, plenty of options there. I think this deserves a whole other talk by itself. Anyway, setting up LODB was a little bit more complicated than I was hoping for. There's some networking stuff that you need to do. But yeah, I won't be going through all of this right now as we're coming up to time. But just like locally, we set up a connection. We define a few variables. So I'm running this in my playground in Singapore. I need to give the cluster and the instance a name. We can construct a connection string, which is kind of similar to your IP and on your local machine. we have a get connection function, and we create a connection pool with SQL Alchemy. And then we obviously want to have a LLM somewhere as well, right? So this is where Vertex AI comes in, and Vertex AI actually bundles a lot of the Google Cloud goodness when it comes to AI and building things, scaling things, deploying things, or monitoring things related to AI. But today we're specifically interested in Gen AI offerings on Google Cloud, and more specifically the Gemini models. They're also available through AI Studio, but GCP makes sure they are properly integrated with other GCP offerings, like, for example, AlloyDB, vector search, etc. And it comes with goodies or enterprise-ready things like identity and access management, which gets more important when you start to deploy stuff, let's say. So quite easily, we can import from LangChain again, Vertex AI embeddings. So this is just replacing our Olama embeddings. And we choose a model which is text embedding 004, and replace that to make our vector store. So this is just the model providing our vectors. We add the documents to our vector store, and actually, let me quickly show you how this looks like in the console. So this is our AlloyDB instance in Google Cloud. Just has a name. It's Postgres 15 compatible. We have one cluster in Singapore with 2 vCPUs and 16 gigs of RAM. So it should be a lot faster than my little local machine here. And as you can see, it already has a little bit of data. So I preloaded our embeddings in there. So going back to the code, I could show you how it looks like in Data Grid, but imagine the same as you just saw before. I'm not going to switch screens again. It's going to take too much time. Basically, everything remains the same, just the embeddings will look a little different because we're using a different model. As simple as that. So yeah, we have the retriever ready. We can ask it to retrieve documents again. And actually, it ran in a half a second instead of 2.5 seconds, which is a 5x performance increase over my local. It's not a proper performance test, but I mean, it looks like it's faster, so that's a good thing. Yeah, I mentioned this. So Gemini has one context window of 2 million tokens right now, and there's also one tool I think that's quite close to my heart is the model garden. So Google still leaves it up to you to choose other models. You can go in there, choose Gemma, but you can also choose Llama, Mistral, or any of the other open models that are out there. So coming up to the end of our rack in the cloud, we just need to define the generative model that we want to use to feed the retrieved documents. So we'll be using Gemini 1.5 here, and then the rest of the chain pretty much looks the same. We just replace plug and play, plug in the other generative model, which is going to be Gemini. And if we run it with the same input, we can see it retrieve different documents. So we have 37, 32, yeah, a few other ones. Let me scroll to the bottom. It's still there. Oh, it's keeping up now. So it actually gives us an explanation of why the best candidate is 2, and it seems like it's a bit more specific about its recommendation. Like it mentions the programming languages. It mentions some specific expertise this candidate has, and it also mentions why other candidates might fall short, which I think was quite interesting to see. Cool. So to finish things up, going back to the slides, I just wanted to quickly go over the new things that you might not have seen yet that were announced at Google I/O 2024 that are kind of related to my talk as well. There were a few Gemini model updates. So there's Gemini 1.5 Flash now, which is a smaller model, which has higher throughput and is more cost efficient. A bigger and better version of Gemini 1.5 Pro was announced. There were a few open source announcements as well. So we have CodeGemma now. So Gemma model, open Gemma model that is more geared at code. PolyGemma introduces video to the Gemma family. And we got a teaser of Gemma 2, which supposedly has similar performance as Llama's 70 billion at half the size, which hopefully turns out to be true. And then lastly, we have agent builder integrations, which I'm actually quite keen to play around with. So there's LangChain on Vertex AI and Llama Index on Vertex AI, which are both in preview right now. That's it for my time. I have a quick survey because it's the first time I do this talk. And so if you guys are open to fill that out, like I just have a few short questions and any suggestions you might have. And if you want to come up to me at the end of the talk, I actually have some, it's not Gemini swag, but it's Apache Beam swag, which is Google Cloud Data Flow related, in case you're aware. And I have some webcam covers and a few torches. So if you come up and show me that you fill out the survey, I can hand you some swag as well. Cool. Any questions before I? Oh, longer? Yeah, gotta be quick. I think there's about. You want the, or you want the torch? No, I want to give a lot of people. You prefer the torch? Okay. It's like this. Torch?
Thank you.
Anyone else? You can come after the talk. I'll finish up first. Any questions? I saw you. Any questions? Okay, then come over. Yeah, go for it. Hmm? No, no stickers. It's webcam covers or torch. This is torch. No worries. You want one? Don't fight. Don't fight. Here. One more. Thank you. It's the last one.
Thank you, Matthias.
Awesome. Can I just?
Yes. Sure.
Cool.
Thank you, Matthias, for his vibrant sharing. I like your energy. We are coming to the end of today's event, so picture time. Yep. Everyone can come to the middle here, so we'll take from here.
Before that, let Amrita give a closing speech where she will share about the Gemini competition with you all.
Oh yeah, just now she was sharing about it halfway.
Just wait for one.
Let's wait for Amrita. But later on, when you leave from this door, everyone should leave on that door only. So we will have some swags for you. Each of you will take 4 badges. It's like a pin, 4 pin and 1 bag. So don't take more, yeah. 4 pins and 1 bag. Thank you. Yeah, Amrita is here.
Nice.
It's already I think Ken is waiting from here.
I think like how we did.
So that was I think
I think it happens like when we move forward, then we.
Can you do it?
Yes.
Yeah. How was it? I was very good when I saw the channel. Oh, right. And probably someone else.
Yeah, I think when it learns, so it's hard to. Okay, everyone. So before we end, I think I promised earlier that I would show you about this competition that we have, right? So let me just quickly play this.
Hey! You may recognize me from my acting work, but my real passion is programming. When I'm in the zone, I'm unstoppable. I don't know if you know this about me, but I'm excited about the future, and Google's Gemini models are tech that can get us there. And you know I'm submitting to Google's new Gemini developer contest, which is so cool it'll blow your mind back to beta. A chance to win for the most creative, useful, and remarkable apps. If you're a dev or dev team that wants to submit, great. But you'll have some catching up to do. I just drank 3 cups of nitro cold brew, and I'm ready to crank out some genius. Time to go wormhole.
Okay. So if any of you are interested in building some incredible apps using the Gemini API, feel free to register. We still have time. 1 second, let me just. Yeah. So the submission ends on the 12th of August. So till then, if you have any interesting ideas or if you would like to explore something, feel free to submit your application, your apps over here. So the first prize is a DeLorean. And apart from that, if you win any of these categories, there would be cash rewards as well. So right now the competition has already started. So as long as you submit by 12th of August, that's good. And after that, by September 4th, you would be hearing back from the team. And yeah. And apart from that, if any of you are interested in joining the Google Cloud Innovators program, feel free to scan the QR code. So once you have been selected, for those who have been selected, you would receive 500 credits. And if any of you have a startup, if it's either in a very beginning stage or if you have been already in the ecosystem for quite some time, you can also scan this QR code. And yeah, you would be receiving updates from the team as well. So if you're relatively new in the in your startup journey, you'd be receiving 2,000 USD worth credits. And if you have been part of the community for quite some time, then it would be 100,000 USD credits. Okay, so gotten the link? All right, so yeah, that's about it. Thank you. I'll pass it over to Sammy. Yeah.
Thank you, Amrita, for sharing the competition. So if you're interested, can join. So now it's a photo session. You all can come to the middle here, especially the people on the side. If you come to the middle, you can also just both. You want, yeah, which side?
Oh, no, the side should be fine. If they come here,
I don't know. What happened to the lights? Should I stand there or you want them?
I think here.
I think you all can stand on this side, then we take from here.
To the front through there.
Our banner is here.
Do we have a poster or something that we can put up?
We can I asked Wedding to display the
Oh,
slides. Where's the
yeah.
is it opening? Okay.
Yes.
Who's the cameraman? Oh, nice.
What's the line?
To the front.
The flow of going out, but not doing